All right, so let's see if we can get through this recording of the warm-up review pretty quickly. So this is a problem about the average temperature outside, average monthly temperature in degrees Fahrenheit, and then the electrical usage. So you would probably think that your average temperature is your x variable, because that would be explaining the electric usage. Another thing that can confirm you thinking that that's the x variable is down here where it has your variables. You've got your y-intercept right here is the constant, and then you have your x variable is the average temp. All right, so we're going to get started. The first question says, is there evidence of an association? Okay, well, you remember that is there evidence of an association? That's statistical evidence. The only way to have statistical evidence is with a p-value, and that means you have to run a test. So we're going to go ahead and start this test and say, do our phantoms model. So our p for our phantoms model is the population parameter. Beta is what we are going to be finding, and beta is the slope of the relationship between average temperature and electricity usage. Okay, the next part of our test is our hypothesis statements. So our null hypothesis would be that nothing is happening. There is no slope, there is no linear relationship, nothing happening. They are independent of each other and not messing with each other. The alternative is that there is a linear relationship, so that means the slope is something else other than 0. So beta is not equal to 0. All right, now for the assumptions, here's where we kind of tend to need a lot of help. So here we go. I decided to separate the I and the R out, so I'm going to call it R line. So we got our R line, the first one meaning random. And so I didn't see that it was randomly selected up there, so I'm going to assume these data are representative of all, whatever this is. Are these households? Yeah, for a home. Of all such, remember that nice little keyword there, all such homes. Okay, perfect. Then I kind of got that covered. All right, the next, the L, is linearity. That is the first step towards seeing that we have a linear model, and that means I need to tell the R value and then define it. So I'm going to look at the data here. I see that R squared, do not use R squared adjusted. R squared is 91.3%. So to get R, I'm going to do the square root of 0.913, which is 0.9555. Notice the sign is negative, and the reason that I know it is negative is because the sign of the slope is negative. So if you have a negative slope, you have a negative correlation. So I have negative 0.9555. So define that. There is a, and I would call that strong, negative linear relationship between average temp and electric usage. Okay, and then also, if you have the picture, which I do, I'm going to label these picture A, B, C. If you have the picture of the basic data, and I do, it's a graph A, average temperature in kilowatt hours, I can see from that it looks pretty strong, negative association. So, as seen in plot A. All right. Next, the I. That is your independence So that's kind of our typical thing where I think home each home's data is independent of other homes' data. Okay. All right, let's see. We've done the R, the L, the I, and so I got to do the N, which stands for normal probability plot. That means that I'm looking to see that the residuals are normally distributed. So let's look and see. Okay, I can see. So what we don't want to do, we do not use this straight up residual plot for this problem. This one's going to be used for equal variance, okay? This one's going to be used for the equal variance. So generally speaking, the two kinds of options that I have is a plot of the residuals this way, and I see that they're somewhat normally distributed. You also might have that normal probability plot that looks kind of like this, and remember it gets more clustered here and then it kind of spreads out, but it looks fairly straight with more density here in the middle where it corresponds with a 0 on both axes. Okay. So plot C is the one that we want to do for this normalness, and that is going to be the one that tells us that from plot C, the residuals are fairly normally distributed. Okay. All right, and our last one, equal variance. Okay. And so that one is the one that I am looking for here in plot B, that I've got equalness of these points on either side of this line. It's not spreading out, it's not got a pattern, it's not fanning out. So from plot B, the residuals are equally varied on both sides of the prediction of the least squares regression line. That's nice and shorter that way. All right, so we need to finalize this and summarize with the linear model applies. And so now the worst part of this whole process is done. Yay. Okay, so there's our assumptions done. Okay, so PHAN. N is the name, and that would be a linear regression t-test. All right, and then T is our test statistics. I'm going to draw the lines on these. Okay, so our test statistics that we need to include are the t-score, the p-value, and the degrees of freedom. So let's go and look at those. So over here on my computer printout. Now, there's a lot of stuff here, and you do not need all of it. I've not been doing this sum of squares, this mean square, this F ratio. This middle section is not needed data. Okay? And here's our t-values and our probability, of which the information on the y-intercept line, other than the y-intercept itself, are never needed. We are not interested in anything on the y-intercept line other than the value of it. So our T ratio is negative 10.2 with a p-value less than 0.0001. Oh, degrees of freedom, let's see, 10. Remember n minus 2. So 12 minus 2 is 10. And so now let's go ahead and write that out. Negative 10.2. Our p-value is about 0. And we have degrees of freedom 10. So we are going to, well, we got the p-value. Obtain, O stands for obtain a p-value and compare it to alpha. So, a p-value of about 0 is less than alpha of 0.05. And so now we're going to make a decision. My decision is to reject. If the p-value is low, we're going to reject that null hypothesis. And now I'm going to conclude. That was make a decision, and so here's my conclusion. Since 0 is less than alpha of 0.05, I reject the slope equaling 0. I have evidence of a linear relationship between average temperature and electricity usage. Okay, now these were interested in 0. Oh, that 0 would be in the interval. Okay, never mind. That's on the panic. All right, that's done for the phantoms for the warm-up.